Okay, let's try a problem. We need some data, don't we?
Yep.
Let's do something simple. Let's use small numbers to start out with. Get my pen. So we'll give you small numbers, and then we'll graduate to big numbers. Okay? So let's start out with 4, 4, 4, 6, 6, 6. Ooh. 2, 2. Let's see. 12 and 18 is what? 30, 34, 3, 3. How about that? What's that? What's that add up to? 40. Is that up to 40?
40.
How many of them are there? 10. That makes it easy for me, right? Yep. So the sum of the xi's is 40, and we've got 10 observations. So the first step over there is to do what? What's the first step? Find the mean. So what's the mean?
4.
Must be 4, right? 40 divided by 10 would be 4. Is that right? Okay. Now, I'm going to show you a way to do the problems that makes it really easy for me to check your work. Okay? Remember, I do not count off for math errors. So this is a long, involved process, and you may make an math error. I will not count off for it if I can find it. Okay? So I'm going to show you a way to organize your work so that I can find any mistakes you make. I'm going to label the tops of the columns. You don't have to, but it helps me to do so. These were my xi's. That's what those guys are. I'm going to put next to that a column of the mean. The mean was 4, so I'm just going to write 4's next to it. Okay? So my first step was to find that mean. Okay? What's my second step say? Subtract them, right? So I'm supposed to subtract them all. What's 4 minus 4? 0. 0, 0. 6 minus 4? 2. 2, 2. 2 minus 4? Negative 2. 2 minus 4? 3 minus 4? Negative 1. Ooh. If I were, now these are the distances from the mean. Some are positive, some are negative. If I were to add them up right now, what would I get?
0.
0. They'd cancel each other out, which would tell me I have no deviation. But I know I do, right?
Yeah.
Right? So that's why I have to go to step 3, which is to square those guys. What's 0 times 0?
0.
Okay. What's 2 times 2? 4, as far as I remember. What's negative 2 times negative 2?
4.
Positive 4. Negative 1 times negative 1.
1.
Positive 1. Okay? So far so good? So we found the mean. We subtracted it from each observation. We squared it. Okay? So far so good?
I think you lost me on that third column. What did you do again?
I'm squaring this. I'm multiplying it times itself. So 0 times 0 is 0.
Okay.
0 times 2 times 2 is 4.
Okay, gotcha.
2 times 2 is 4. Okay? Okay? So I've squared it. So I found the mean, subtracted from each observation, squared it. Okay? So I've done all of this part. Found the mean, subtracted it, squared it. I've done that part. I've got to do the E. What's the big E tell me to do? Add up. So step 4 is to sum them. Add the xi's minus x bars squared. Sounds really terrible, doesn't it? What do? 4 and 4 and 4 and 4 and 4. So 1, 2, 3, 4, 5 fours. That would give me what?
20.
And 2 ones,
22.
22. Is that right? 4, 8, 12, 16, 22. Now see, it looks really ugly. Sum up the xi's minus x bars squared, but it's really just adding a column of numbers. Okay, what do I do now? What's step 5?
Find the answer by n minus 1.
Divide by n minus 1. What's in this case?
10.
10. So n minus 1 is
9.
9. So now I need to divide 22 by 9. Oh, I can't do that in my head. Let's see. On 22 divided by 9 is 2.4. 2.4. Now look how ugly that is. But it's 22 divided by 9. Am I done?
No.
What do I have to do?
Find the
Square root. So step number 6 says take the square root. The square root of 2.4. Where's my calculator? Let's see. I got to do second. Square root 2.4. I got 1.549. Is that right?
At 1.56.
Well, what did you take the square root of?
2.4.
Just 2.4 or 2.44?
2.4.
Just 2.4. I get 1.549.
I get my calculator rounds, so I get 1.55.
1.5.
Yeah, 1.5.
1.5. Okay. If your calculator is rounding to 2 decimal places, so you get 1.55, you would round to 1.6, right?
You're okay with that?
I got 1.549, so I'm going to round to 1.5. Okay, so that's why you want to show me all their work, because if I see you're dividing, if you're taking the square root of 2.4 and you get something slightly different from mine, I know that's what it is. Okay, so I'm going to have 1.5. So the standard deviation is 1.5. That's telling me on average these observations are 1.5 units away from the mean. Okay? Now you can see we've got several of them that are exactly on the mean, some that are above and some that are below. Okay? And so it's giving you the average distance. The average of these distances from the mean is 1.5 units. Now remember we said over here, if this standard deviation is large, the data is all spread out. How large is too large? Well, a general rule is if the standard deviation is more than half the mean, that's large. So if the standard deviation is more than half the mean, you'll get some standard deviations that are bigger than the mean. I mean, they'll get a huge standard. But if the standard deviation is bigger than half the mean, it's large. What's the mean in this case? 4. So half of that would be 2. And we got a standard deviation of 1.5. So it's just under. So I'd say this is okay. This data set is still compact. Okay? But if I'd gotten a standard deviation of 2.5, I would say it's disperse. Okay? So less than half the mean compact, more than half the mean disperse. Copacetic? Okay? All right. We're going to do 2 problems together that are nasty. Okay? Because if we do the nasty ones together, you can do the unnasty ones on your own. Right? So we give the hard ones in class and the easier ones outside. Oh, come on! You're just grumbling. Here, these are the notes. I'm also passing around my notes, which are not very good, I will admit. They're not very good. I was talking to Dave Grolton. Everybody know Dave? Dave's going to start teaching is his, he's not taught it here, he's taught it other places in his district. So we were talking about it. Dave, you know, is a mathematician. So he gets all excited about that. I don't. so we were talking today, and I told him, well, there's nothing to it. And he's like, there's nothing to it. He's still going all the theory and everything behind you. I'm like, okay, right. Okay. All right, we've got Babe Ruth, and we've got Mark McGuire, okay? We'll start with the Babe. I'll do it. If you want to do it on, a lot of people like to do these on lined paper.